Now let's see some of the alloys which are formed by these various metals which we have already encountered. First and foremost thing, what is an alloy? Alloy is a substance prepared by adding other metals or a non-metal to the base metal in appropriate proportion to obtain a desired properties. Let's see some of them. To begin with it, let's take copper zinc alloy. Copper zinc alloy, a combination of both, results into various alloys such as brass, bronze, German silver, gunmetal, bell metal. In case of brass, the metal present in it is copper zinc with various percentages. It is generally giving us a very hard, lustrous, malleable, ductile alloy, which is used for electrical fittings, medals, etc. In case of bronze, it is a combination of copper, zinc, tin, that is Sn, which is hard, attractive, takes up polish. It is used in statues, medals and coin preparations. Whereas German silver, it involves copper, zinc, nickel. It is white and light like silver. It is generally used for decorating any articles. Whereas gunmetal, which contains Cu, Zn, Sn, Pb, which is hard, easily it can be cast. It is used in barrels, bearings, etc. Bell metal contains Cu and Sn, which is brittle, sonorous, that is giving out sound when struck against any surface. It is used in preparation of bells, gongs and statues. Now let's see some of the alloys of aluminium, which we have already seen it. They are duralumin, which is a combination of aluminium, magnesium, manganese and copper. Again, they may vary in percentage. It is very light, stronger than aluminium. They are used for aircrafts, light tools and ships. Whereas magnesium is a combination of aluminium and magnesium. It is light, strong, corrosion resistant, used in aircrafts and also balance, that is beams of a balance. Whereas alnico alloys is a combination of aluminium, nickel, cobalt and iron. It is light, shiny, corrosion resistant, which are generally used in magnets. Whereas lead alloys involve shoulder and type metal. Shoulder involved lead, that is Pb, along with Sn. They have a low melting point, high tensile strength. They can be used for welding, electrical fuse, etc. Whereas type metal, which is a combination of Pb, Sn and Sb, having a low melting point, easily cast and expand. So they are used for printing blocks. Whereas iron alloys such as stainless steel, which is a combination of iron Fe with nickel Ni, chromium Cr, carbon C, is lustrous, hard, corrosion resistant. They are used for surgical instruments. Whereas nickel steel is a combination of Fe, Ni and C, which is elastic, high tensile strength, generally used for cable, aircrafts, etc. Whereas tungsten steel is a combination of Fe, W and C. It is very hard, corrosion resistant and used in high speed machines part. Now since we have already covered up the entire chapter, let's see some application oriented question with respect to this topic. The question which might be framed will be as follows. To begin with it, compare the properties of a typical metal and a non-metal on the basis of following points. First, electronic configuration. Second, nature of oxide. Third, oxidizing or reducing agent. Fourth, conductivity of heat and electricity. Let's take the first point. With respect to metal, the electronic configuration will be 1, 2, 3 valence electrons, whereas non-metal will have 4, 5, 6, 7 valence electron. Now, with respect to nature of oxide, metal always forms basic oxide, whereas non-metal will always form acidic oxide. With respect to agent, whether it is oxidizing or reducing agent, metals are donor of electrons, so they are powerful reducing agents, whereas non-metal are accepting electron, so they are oxidizing agents. With respect to conductivity of heat and electricity, metals are always good conductor, whereas non-metals are bad conductor of heat and electricity. Now let's take one more question. To protect iron from rusting, it is coated with a thin layer of zinc. Name the process and also name a non-metal that has a metallic luster and it sublimes on heating. The answer for the first part is, the process name is galvanizing, and the non-metal which sublimes is iodine. Now, let's take one more question. What is observed when a small piece of iron is placed in copper sulphate solution? Your observation is a red shiny metal precipitate out. Another question. Match the substance from the list of substance given below, that is ammonium sulphate, lead carbonate, chlorine, copper nitrate, ferrous sulphate. A white solid which gives a yellow residue on heating. Which compound is it? Answer for that is lead carbonate. Now, we have seen some of the application oriented questions. Now let's talk about board point of view. With respect to board, this topic carries approximately 12 to 14 marks. So, it becomes very important for you to know about this topic. This topic mainly has the extraction part, that is extraction of the metals, along with its alloy and its application, and also the reaction with respect to air, acid, then water, then displacement reaction or reducing property, etc. So Let's see some of the question which was asked in board. In the year 2003, a question asked was, write the balance equation for the following reaction, and that is, aluminium powder is warmed with hot and concentrated caustic soda solution. Caustic soda, which already you know it is the other name for sodium hydroxide. So, whenever aluminium combines with sodium hydroxide, it always forms sodium aluminate. The reaction for which will be 2Al plus 2NaOH plus 2H2O will give you 2NaAlO2 along with 3H2 gas. In the year 2004, a question asked was, write the equation for the reaction of zinc with the following. First, NaOH. Second, dilute sulfuric acid. Third, with copper sulfate. The reaction in the first case will be zinc Zn treated with 2NaOH, that is sodium hydroxide, also known as caustic soda. It will form sodium zincate, the formula for which will be Na2ZnO2. Along with that, you get hydrogen gas. In the second case, with respect to sulfuric acid, that is dilute sulfuric acid, zinc Zn plus H2SO4 dilute will give you ZnSO4, that is zinc sulfate, along with hydrogen gas. The third, with respect to copper sulfate, CuSO4 plus zinc. Zinc is higher in the activity series, so it is going to displace copper from copper sulfate. So the formula will be CuSO4 plus Zn will give you ZnSO4 plus Cu. In the year 2005, a question asked was, calcium, copper, lead, aluminium, zinc, chromium, magnesium, iron. Among them, choose the major metal from the list given above to make the following alloys. First, stainless steel. Second, brass. With respect to the first case, that is stainless steel, we use iron, that is Fe, along with chromium, that is Cr. With respect to brass, the major metals are copper, Cu, and zinc, Zn. In the year 2006, a question asked was, name the following. A metal which is liquid at room temperature. The answer for that is mercury. Mercury is a metal which is liquid at room temperature. The second part was a compound which is added to lower the fusion temperature of the electrolytic bath in the extraction of aluminium. The answer for which was cryolite, that is Na3Al(F6). The third question was, the process of heating an ore to a very high temperature in the presence of air is known as, the answer is roasting. The last part was the compound formed by the reaction between calcium oxide and silica during the extraction of iron. The answer for that is calcium silicate, that is CaSiO3, calcium silicate. In the year 2007, a question asked was, from the list of the characteristic given below, select the 5 which are relevant to a non-metal and their compounds. The option given to us was as follows: A. Ductile, B. Conduct electricity, C. Brittle, D. Acidic oxide, E. Basic oxide, F. Discharge at anode, H. Ionic chloride, I. Covalent chloride, J. Reaction with dilute sulfuric acid yields hydrogen, K. 1, 2 or 3 valence electron, L. 5, 6 or 7 valence electron. Write the 5 letters corresponding to the correct statement, and the answer was C, D, F, I, L. In the year 2008, a question asked was, brass is an alloy of, option A was copper and tin, B was copper and zinc, C was zinc and lead, D was lead and tin. The correct answer for this question is B, an alloy of copper and zinc. Now, since we have seen the entire chapter with respect to board point of view also, let's see the summary of the whole thing, what we had done it, a brain mapping of the entire chapter. When we started this topic, we had seen the definition of a metal and a non-metal. Then we went ahead to differentiate between metal and non-metal on the basis of chemical properties and physical properties. After which, we went ahead to see the various steps involved in metallurgy and the various terms used in it. After which, we actually went ahead with the extraction phenomenon to see the extraction of a metal, that is aluminium, zinc and iron. After which, we had seen their properties with respect to chemical properties, with respect to physical properties. And then we went ahead with the alloy formation and the application of the alloys, the uses of it in various fields in our day-to-day life. So, metals becomes very important to us. Because of the study of this metal, we know that which metal is beneficial to us and which is harmful to us. For example, you wear gold chains, you wear earrings, you have so many articles, ornaments made up of gold, platinum, etc. But you don't make ornaments with sodium. Reason? Sodium is dangerous. The moment you have any article or ornaments made up of sodium, you won't be there to wear it.